So I want to introduce the discussion of limits, but this is going to be an informal discussion of limits. I will not introduce quite yet my precise definition of a limit. Now, according to my pretty picture, is it not true that as x approaches a from the left-hand side, the corresponding y values approach that numerical value I labeled m? When I use a superscript negative sign, it simply means x is approaching a from the left. Notice, however, as x approaches a from the right-hand side, the corresponding y values on the graph are actually approaching the number I labeled as nil. But I don't like the notation, so I'd like to tie up the notation a little bit tighter. Instead of writing all this out, I will equivalently say that the limit of f of x as x approaches a from the left-hand side is indeed equal to n. And I will likewise say that as x approaches a from the right, the y values approach L, or write more concisely, the limit of f of x as x approaches a from the right-hand side is indeed equal to L. Now, if I do not use any superscripts, then this is understood to be a two-sided limit. This two-sided limit is going to exist as long as these two one-sided limits agree. And in this particular case, they don't. So I will say the limit does not exist. Well, let's see if we can put this to practice. Now that I've introduced the notation and the language for limits, at least informally, take a peek at the first question. Look at my graph. As x approaches -3 from both sides simultaneously, what do the corresponding y values seem to be doing? Well, as x approaches -3 from both sides, the y values seem to be decreasing outbound on both sides. And so I might write this limit equals -infinity. I don't really say that out loud in English. I say instead that as x approaches -3 from both sides simultaneously, the corresponding y values decrease without bound. This is not a limit question. This has nothing to do with movement. I'm simply asking, if you jump, plant your feet at -3 on the x-axis, look up or down, can you identify what the corresponding y value is? And the answer is no, I can't. There's a vertical asymptote there. So I will say that f is undefined at -3. Now, as x approaches -1 from the left-hand side, the corresponding y values seem to be getting closer and closer to 4, so the limit of f of x is equal to 4 as x approaches -1 from the left. From the right is a different number, but that's a two-sided limit. Here, the one-sided limits do not agree, so this two-sided limit does not exist. Now, algebraically, the corresponding y value on the graph of f at x equals -1 is specifically 4, because that's where I've got the dot closed in, and the y value of the closed dot is positive 4. Now, take a peek at this question. As x approaches 2 from both sides, the corresponding y values approach 7. But specifically when x is 2, y is exactly equal to positive 10. Notice how what I get is not what I expect. As I approach 7 from the left-hand side or from the right-hand side, I will generate this as well as this, respectively. But that means a two-sided limit does not exist. And of course, there is no corresponding y value there. Sorry, running out of room. As a matter of fact, as x approaches 9 from both sides simultaneously, the y values seem to be getting closer and closer to 7. So the limit as x goes to 9 of f of x is equal to 7. Albeit, yet again, My function is not defined at x equals 9. There is no closed dot up or down. Notice how I use this language of being undefined when there's no corresponding y by there. But when the limit does not exist, I have a tendency to use this phrase in English, does not exist. Well, I think that's going to be sufficient to get you started.